Welcome to the lecture. Today we are going to see the problems on supernodal analysis. Now, when we go for supernode concept, when the voltage source are present between two nodes, in that case we will go for the supernodal analysis. Now we will see the example problems on supernodal analysis. Determine the current in the 5 ohm resistor for the given network. So here they have given the network with the 10 amps current source, 20 volt source and 10 volt source. Now the 20 volt source is present between two nodes. So in this given circuit we have to go for the supernodal analysis. Now so step 1 is first we have to identify the number of nodes in the given circuit and assign one node as a reference node. Now defaultly we can select the bottom node as the reference node and we have to assume the remaining nodes. Let V1 be the voltage at node 1, V2 be the voltage at node 2 and V3 be the voltage at node 3. So in this case node 2 and node 3 forms super node. The next step, assign all the currents are leaving at each node. Now at node 1 we have assumed the currents are leaving and similarly node 2 the currents are leaving and node 3 the currents are leaving. Now apply KCL at each node. Apply KCL at node 1. So first you have to assume that whether we are having any current source are connected at node 1. Yes, the 10 amps current source are connected at node 1. Then we have to check whether it is incoming current or outgoing current. So the 10 amp current is incoming to the node 1. So that we have to write the equation as 10 equal to V1 divided by 3 plus V1 minus V2 divided by 2. Now combine V1 and V2. So V1 into 1 by 3 plus 1 by 2 minus V2 by 2. So you can simplify the equations. We get 0.83 V1 minus 0.5 V2. So in terms of simultaneous equations format, we can write 0.83 V1 minus 0.5 V2 equal to 10. So take this as equation number 1. Now we can apply the KCL for node 2 and node 3. So before applying the KCL, we have to check whether the node 2 and node 3 forms supernode. So in the given circuit, node 2 and node 3 forms supernode. So by writing the equations for that node voltage, we have to eliminate the voltage source. So we have to write node 2 and node 3 form supernode. So we have to eliminate the voltage source by writing the equations. Now the positive terminal which is connected at node 2, so that we can write V2 minus V3 equal to 20. So take this as equation number 2. Now combine node 2 and 3 and apply KCL. So now combinedly we have to apply the KCL for node 2 and node 3. So is there any current source connected at node 2 and node 3 means there is no current sources are connected, so that we can write 0 equal to V2 minus V1 divided by 2 plus V2 divided by 1 plus V3 divided by 2 plus V3 minus 10 divided by 5. So this is the node equations for the combined node 2 and node 3. Now separate V1 and V1, V2 and V3. So we can write the equation in terms of V1, V2, V3. So by separating the equations, minus V1 by 2, then combine the V2 by taking V2 outside. So V2 equal to, so V2 into 1 by 2 plus 1, that's all. Then for V3, by taking V3 outside, we will get 1 by 2 plus 1 by 5. Then minus 10 by 5. Now we can simplify these equations. We will get minus 0.5 V1. Then if you simplify this, we will get 1.5 V2. Then for V3, we will get 0.7 V3 minus 2. So right, we can write the equation in terms of simultaneous form. So minus 0.5 V1 plus 1.5 V2 plus 0.7 V3 equal to 2. Take this as equation number 3. Now solve the equation 1, 2 and 3. You will get the node voltage V1, V2 and V3. Now solve equation 1, 2 and 3. We solve that, we will get the values for V1 as 19.04 volt, V2 11.6 volt. For V3 it is minus 8.4 volt. But still the problem not completed. Here they are asking current through 5 ohm resistor. Where the 5 ohm resistor is connected, which is connected at node 3. So we have to write the equation for current through 5 ohm resistor. So at last the current through 5 ohm resistor is given by I 5 ohm equal to V3 minus 10 divided by 5. So we know that voltage at V3 is minus 8.4. So we can substitute the value of V3, that is minus 8.4 minus 10 divided by 5. So at last I 5 ohm we will get this minus 18.4 divided by 5. It is current through 5 ohm resistor equal to minus 3.68 amps.